our last sheet, finally, 3C. We only have 2 sections on this one, so I'm going to try and do this video just in one shot. So we're looking at average rate of change, and average rate of change basically is slope, but what it's telling us is that since it's an average rate of change, it's not linear, because linear has a consistent rate of change, so we wouldn't need to take an average. So average rate of change implies that our graph isn't linear. So since we did a lot with exponential, I put 2 exponential examples on this one. To find the average rate of change, we're just going to use the formula for slope. So we're going to do y minus y over x minus x. And then you just need to use the ordered pairs. You're going to be given the 2 x's, and you're going to figure out the ordered pairs to use for the y's. So, number 38. Calculate the average rate, the rate of change over the interval 1 to 3. So these are 2 x values. That's the first x, and that's the second x. So what I need to do is figure out what my ordered pairs are. I know it's 1 something and it's 3 something. So when you get those 2 numbers, those are your 2 x's. So the point at x is 1 looks like right here, looks like 1, 2. And for 3, it looks like it's at 3, 8. So now I'm just going to use those 2 points to find the slope. So 8 minus 2 is going to be 6. 3 minus 1 is going to be 2. So the average rate of change is 3. All right, on number 39, same idea, just different way to write it. Calculate the rate of change between -2 and +1. So -2 is right there, and then +1 is right there. So first, these are my 2 x's that I've been given. So I need to use the graph to find the y's. So at -2, I think 1 is probably right there, right? So this looks like it might be 1.5. So I'm going to say 1.5. And then at 1, it looks like 5. 1.5 for that one. So this one might not be as nice, but we'll see what happens. Okay, so we're just going to find the slope. So 5 minus 1.5 is going to be 3.5. And then 1 minus -2 is going to be 3. And we're not going to leave this like this. So what we can do, probably the easiest thing, is if we move this decimal over a spot, we need to move this decimal over a spot. So that would make this 35 over 30. And I can reduce that by 5, and I would get 7 over 6. So that tells me that the rate of change is 7 over 6. All right, moving on, same idea, just continued. When we talk about the greatest rate of change, we're looking for the largest slope, which is going to be the steepest part of the graph. And then the lowest rate of change is going to be the slope that's closest to 0, because remember, the slope of 0 is a horizontal line. So the closer it gets to being horizontal, the closer it's getting to 0. So that's going to be our lowest rate of change. We don't need to worry about the sign, because the sign tells us the direction. So it's going to tell us whether the slope is positive or negative. So that doesn't affect the value of it. So we have 2 questions here. I use the same graph. So on number 40, based on the graph, what is the greatest rate of change for the function? So what I want to do is look for the steepest part of the graph, and I would call this right here the steepest part of the graph. So this point and this point. And just so it doesn't make it too difficult, I'm going to use the whole numbers here. So this one looks like the point 14.1. And this one looks like the point 23. So now I'm going to find the slope of those 2, and that's going to be the greatest rate of change. So 3 minus 1 is going to be 2. 20 minus 14 is going to be 6, and that reduces to 1/3. So the greatest rate of change is 1/3. All right, so now looking at the graph, what is the least rate of change? So the smallest rate of change is going to be the flattest 1. Now, we do have some horizontal ones, so that would absolutely be the least rate of change. So let's go for the next one just to make it a little bit tricky. So this doesn't, these are hard to tell because they don't land on perfect numbers here, but this one looks like it's up 1 and over 6. This one looks like it would be up 1 and maybe over 8. So I think this one is not as steep as that one. Let's see, how does this one look? Yeah, this one is pretty close too. So I would go for either this one right here or this one down here, but just because of its size, I'm going to go here. And I guess we'd call that 5. So this one, if I use 0, 0, 0, 0 is that one, and over 5 and up 0.5 on that one. Alright, so finding the slope of this, so y minus y is 0.5 over x minus x. And just like we did up there, if we move this over, then we're going to move this over. So that would be the same as 5 over 50, which would reduce to 1/10. So, except for the slope being 0, which is completely horizontal, that would be the lowest rate of change for that function. All right, that concludes Unit 3. Thank God.